Assalamualaikum warahmatullahi wabarakatuh. Today we from 2BMMV section 1/1 group C are going to present on the subject fluid mechanics. This presentation will be on the assignment given entitled pressure in pipes. Without further ado, I will let our first presenter Norma to explain about the introduction.
Thank you, Alif. Good day, everyone. I am NORMA binti BADRULHISHAM, metric number B0920100346. Now, I will present about the introduction of the assignment. This assignment will be using a water fertigation system to simulate losses, pressure distribution, velocity, and flow rate at a different axis of a flowing pipe. We are using a Bernoulli's principle to analyze and generate inference on this activity. We are also going to construct and test two different configurations in order to assess and analyze the flow and pressure variation in pipes throughout a particular length of a pipe. And we are also be performing an experimental and simulation exercise of the flow in hose pipe. For example, for simulation, we will be using ANSYS 16 software. Based on the assignment given, we then prepared two types of pipe layouts, which are the straight line and the closed loop. After we have built up the pipe configurations, there are several data that need to be obtained, which are the velocity, maximum attainable water jet, and lastly, a maximum pressure in pipe. As you can see on the table below, the straight line water hose configuration is on the first column, and the closed loop water hose configuration is on the second column. Now, I will pass to IZANI to continue the presentation.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Norma. Before I start the presentation, I'm going to introduce myself. My name is NURUL IZANI AFIFA binti AHMAD, and my metric number is B0920100073. I'm going to explain about theory related to this assignment, which is pressure in pipe. The flow rate within the pipe is defined as the volume of fluid each second that is passing through a cross-sectional of the pipe. It turns out that under the assumption of uniform flow within the pipe, the flow rate within, which is often represented by the symbol Q, can be directly related to the fluid speed V and a measure of the pipe cross-sectional area, or A. In terms of these variables, the flow rate Q can be expressed as Q equal to AV. From this relationship, it can be assumed that flow rate is directly proportional to the average velocity and the size of cross-sectional area. It means that if the flow Q is held constant when the area A decreases, the velocity V must be increased proportionally. Next, to understand the relationship between the pressure drop across a pipeline and the flow rate through that pipeline, we need to go back to one of the most important fundamental laws that govern the flow of fluid in pipe, which is the conservation of energy, which for incompressible liquid can be expressed using the Bernoulli equation. From what we can see, the photo on the left side of the slide, which is Daniel Bernoulli, a Swiss mathematician and physicist, he theorized that the total energy of a fluid remains constant along a streamline, assuming no work is done on or by the fluid and no heat is transferred into or out of the fluid. In the total energy of the fluid is the sum of the energy of the fluid possesses due to its elevation, velocity, and static pressure. That's all from me. Now I pass to NAJMI to continue the presentation.
Thank you, IZANI. I am Muhammad HAIQAL bin KAMARUDDIN. My metric number is B0920100168. So I will present for methodology, simulation data, and conclusion section. So for methodology, the way we carried out this task is to run an experiment with two different pipe arrangement, which is as we can see in figure 1, it is a straight line water hose configuration, and figure 2, closed loop water hose configuration. And for simulation part, we use ANSYS software to obtain result and compare to the experiment. And here is the simulation result for part 2A, which is a straight line water hose. Inlet pressure, outlet pressure, inlet velocity, inlet density, outlet density, inlet viscosity, outlet viscosity, mesh inlet, mesh outlet. So part 2B, closed loop water hose. Inlet pressure, outlet pressure, inlet velocity, inlet density, outlet density, inlet viscosity, outlet viscosity, mesh inlet, mesh outlet. And now I will pass to AZRUL HAKIM for next part.
Thank you to NAJMI HAIQAL. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrul bin Ahmad, and I will explain about the procedure. So this assignment has been given two experiments. The first one is about water jet, and secondly there are two tasks which are straight line water hose and closed loop water hose. For the water jet experiment, firstly we connect the pipe hose to the valve and then open the valve to the maximum that the water can reach. After that, determine the maximum achievable water by using a measuring tape. This experiment is about to calculate the flow rate and the velocity from a hose pipe. And from that, we can calculate the pressure in pipe based on Bernoulli equation. Next, for the straight line water hose. Firstly, we make 3 holes on the straight pipe hose. We're using a cutter and screwdriver to make the hole. Next, the length between one hole to another is 30 centimeter, and we put the single connector into each hole. We use a stopper at the end of pipe to prevent the water from coming out. Lastly, turn on the water tap to the highest and use a stopwatch to record the time taken of the water to full for 1 liter. And for the last task, closed loop water hose. First, we cut the pipe hose into 100 centimeter, and then we connect it to the pipe hose with holes that has been used by using T connector to make a loop pipe hose. Next, open the water valve to the maximum and we take the time reading for each hole where the water can fill up to 1 liter. And then we repeat the experiment 3 times for each hole. That's all from me for procedure part. And before I pass to my friend SHARIZAL to explain the calculation part, I will show you the video of conducting the experiment. Thank you.
Assalamualaikum and good day for the lecturer and all my friends. My name is SHARIZAL bin SHAFIE. My register number B09201003. Before I continue more, I want to say thank you to Muhammad Azrul HAKIM was explain the procedure for this task. Now I want to present my part is the data and calculation in this task. In this experiment, it has two tasks to conduct. First, the task for find flow rate of the water, velocity of the water, and maximum pressure in the pipe will use for assessment of the assignment. Now we can see at the slide. First, the flow rate we can calculate based on the formula. Flow rate equal to volume divided time taken. So see on the slide. When we substitute the data of the volume and time taken, we can get the flow rate is 4.926 multiply 10 power of -4 meter cube over second. Next, the velocity we can get from the formula who we see on the slide is velocity equal to flow rate divide cross sectional area. When we substitute the data, we can get the velocity is 3.2 meter over second. Lastly, for the maximum of pressure in pipe, we get from Bernoulli formula. The formula we can see on the slide. Then when we substitute the data, we can get pressure is 107.52 kilopascal. On the next slide, we can see for the data and calculation for task 2. Task 2, we must conduct two type of method. First is the straight line water hose configuration. In this method, we was measured the time taken for full in 1 liter water of measuring jug for the 3 hole. This task also to calculate the flow rate and velocity. Okay guys, on the last slide, we can see the second method for task 2. The method is the closed loop water hose configuration. In this method, we was also measured the time taken to full in 1 liter water of measuring jug for the 3 hole. Same with method 1. Then to calculate the flow rate and velocity, also we use the same formula we can see on the slide. That's all for my part, the data and calculation. Now I want to say thank you for all, and I want to pass the presentation to next presenter is Muhammad Alif Nazafi. Thank you.
Thank you, SHARIZAL, for the explanation of data and calculation. My name is Muhammad Alif Nazafi bin RISMAN, matrix number B0920101192. Now it is my turn to present on the discussion part. In configuration 2A, the hole closest to the water source, which is hole 1, has the greatest flow rate and velocity but the lowest pressure, whereas the hole furthest from the water source, which is hole 3, has the lowest flow rate and velocity but the highest pressure. In configuration 2B, the water is flowing in a closed loop, but the water flows from the tap via a T connector, splitting it into two paths, left and right. The pressure in the pipe and velocity of the water act the same as in configuration 2A. The hole closest to the water source, which is hole 1 and 3, has the greatest flow rate and velocity but the lowest pressure, whereas the hole furthest from the water source, which is hole 2, has the lowest flow rate and velocity but the highest pressure. By using Bernoulli's principle, lower pressure zones have greater fluid speed, whereas higher pressure regions have lower fluid speed. For the straight line configuration gives an inconsistent output on all holes for fertigation. The first hole produces more water per second, and the production diminishes as one moves further from the pipe, while a closed loop gives a consistent and almost identical output across all holes drilled. The velocity of water that erupts out of the hole is about the same overall. So in contrast, the result of the calculated experiment data deviates somewhat from the simulation data. This is because of the experiment's random and systematic fault in obtaining readings. When the stopwatch is stopped too soon or too late, the parallax mistake occurs. This might be avoided by taking the reading for the water that filled the 1 liter jar more than 3 times and averaging the results. So that's all from me. Now I will pass to NAJMI HAIQAL to conclude our presentation for today.
Thank you, Alif. So for the last part for this assignment is conclusion. For this experiment was carried out as a result of a collaborative conversation regarding the briefing for this experiment, which run the experiment and preparation for the equipment. And the experiment was conducted at the parking lot of College Kediaman Lestari UTEM. And this experiment necessitates the use of ANSYS software for simulation, and the outcome result was successfully recorded. The volume and height of water were measured in order to calculate the water pressure using Bernoulli's equation. So when the experiment was carried out, it was discovered that the water pressure for each activity depends on its flow rate reading. It is also demonstrate that water pressure varies depending on the work at hand. Finally, by presenting the report in a professional manner, this experiment was able to meet all of its objectives. That's all from us. Thank you and Assalamualaikum.